Here we go. We have a question: sorting elements of an array by frequency. So you have given an array of integer ARR. We need to sort the array according to the frequency of elements. That is, elements that have higher frequency come first, and if there's a tie, we prioritize smaller element. So in this case, 5 frequency is 2 and 4 frequency is also 2. So we need to prioritize smaller element. So first 4 comes, then 5, then 6, because 6 frequency is 1. So let's build the approach. We have this example. As you can see, array may be not sorted. So how do we find the frequency? First, we need to sort this array. First, we sort this array. So after sorting this array, the maximum frequency can have is if all the elements are same. So let's suppose a element, a array has all the elements and all the elements are same. So the maximum frequency we can have is n. So in this approach, what we do is we build a array or vector. So we need to put an element according to its frequency, and the maximum frequency we can have is n. So we need excess of n. In this case, n is 6. We have 6 elements. So let's build 7. Let's build an array of length 7. Now we count the frequency of an element. First we have 4. Its frequency is 1. So we place 4 in this cell. Next we have 5. We count its frequency and place an element here. We have an element 5 whose frequency is 4. Next we have 6. 6 frequency is also 1. So we have a smaller element. Now all the elements, because array is sorted, all the elements that comes after this will have to be the greater element than before. So 6 frequency is also 1. So 6 belongs here. So this is a 2D array or 2D list. This is a list or a vector, a 2D list or vector. So after building this 2D array, we need the element which have higher frequency. So higher frequency element present on right hand side. So we traverse right to left. So its frequency, we does not have an element whose frequency is 6. No element whose frequency is 5. Now we have an element whose frequency is 5. So we place 5, and we need to place 5 4 times. So we run a loop and iterate 4 times. No element here, no element here. Next we have some elements here. First we have 4. So 4 frequency is 1. So we run a loop for 4 only one time. Next we have element 6. So that's how we build our answer. So let's code this. First we have n. Then we need to sort this array and a frequency array. This is a 2D list or vector, and its size is n plus 1, because there may be a possibility that all the elements are same. Then we need an element with its frequency. So we have first element, we have element variable unknown number, first element, and its frequency is 1. Next we iterate from 1 onwards, and if it's equal, then we increment our frequency variable. If it is not equal, then we place into our frequency array on frequency slot, and we add and we add this current element. After doing so, we have this element. So this is a new element. So its frequency currently is 1 and number is current element. There may be a possibility that all the elements are same and we never go inside this else block. So at the end we also have to add number in the frequency slot. After building this 2D vector, we need to traverse from backwards and build our answer list. So start traversing from backwards. I have a variable f. So f starts from n and reach till 0. And we have temporary list. So it represent the current list. So because we have a 2D list and on every slot we have a list. So I am getting this list on current slot. So we iterate on every element. Suppose in this case 4 occurs 2 times and 5 occur 2 times. So on one slot, first we have 4 element, next we have 5 element. On second slot, so we need to add 4 2 times and 5 2 times. So first I am getting the element and next we have to iterate or add frequency number of times this loop. So I so then we are pushing or adding this current element into our answer. At the end we are returning our answer. Let's submit this code. And solution is successfully submitted. If I talk about time and space complexity, first we are sorting our array, it's n log n. Next we have this for loop, so its time complexity is order of n. Next we have this. In this we are iterating on every slot, but some slots may be empty, so we are not traversing this for loop on every cell. We are only traversing this for loop for if a value is present in our array. Next we are adding this current element frequency number of times, and frequency number of times it is already available in the array ARR which is given. So its total time complexity is order of n, and the overall time complexity is n log n, and space complexity is n plus 1. So let's go to second approach. So we track the variable with its frequency and store it into a pair. So first we have this 4. 4 frequency is 1. So we have one frequency and the element is 4. Next we have 5. Its frequency is 4. So frequency then value. Here represents frequency and then value. Next we have 6. Its frequency is 1 and element is 6. So after building this pair, we need to sort according to the greater frequency, and if there's a tie, we need to prioritize smaller element. So we need to build a custom comparator. So it will give us first 4 5. Next there's a tie between these two guys, so we need to prioritize this second value which is smaller. So first 1 4 comes, then 1 6 comes. So we have this value, which means 4 number of times 5 element occur. So we run a loop 4 number of times and we add this second element. So that's how this approach or algorithm will work. Let's code this. We have n, then we sort it. So I am using pair here. So we can define type def and define pair and give it a short form. I am giving PR. So we have a vector of PR which is a pair. and its name is frequency array. Then we have value and frequency. The same thing, if it is equal, we increment frequency, else we add and change our frequency. After building this frequency array and adding on the frequency array, this is a vector and I am adding each and every pair. First value is frequency, second value is a number. Then we need to sort it. We need to sort this frequency array with a custom comparator. So let's give it a custom comparator. We have frequency, then number. A pair here, this is a pair. First value is a frequency. So if there's a tie between the frequency, we need to prioritize smaller element. So element present is on second value. We will prioritize smaller element. Else, if the frequency is greater, we need to prioritize the greater frequency element first. So let's pass this comparator here, frequency then value, frequency then number. We need to iterate in this vector frequency array, and first value is the frequency, so we run a loop frequency number of times and add the second element. So that's how we add the second element and at the end return our answer. Let's submit this, and in between let's talk about time and space complexity. We are sorting our input array, so its time complexity is n log n. Next we are iterating, so it is still order of n. Next we are sorting. So in worst case, let's suppose every element occur only one time, so it will be n log n. Next we have this for loop, so we are traversing an element frequency number of times, which is already given in the array ARR. So this approach, overall time complexity is order n log n, but we have to do it for 2 times. Although this is a bit optimization in terms of space, so that's how this algorithm will work. If you guys have any doubt, feel free to ask in the comment section. Code is given in the description box. Thank you all for watching.